Trigonometric identities is something that's very common in higher maths. Trigonometry. Okay, now trigonometric identities, what are they? When we say trigonometric identities, we mean something specific. Before that, a little bit of a review. Now, what is the meaning of an expression? What is an expression? An expression is actually numbers, symbols, and some mathematical operation like plus, minus, multiplication, division. That's an expression. Next comes the question of what's an equation? An equation is simply an expression followed by an equal to sign followed by a zero. Now, what can we do to an expression? We can simplify an expression, or we can factorize an expression. And in case of an equation, we can always solve an equation, meaning finding the unknown value of x, also known as the root of x. So whenever we have an equation, we have to solve it and find the unknown value of x. Now when it comes about expressions or equations, we have some very common things in math. They look like this. Is an expression ax plus b called a linear expression, or a first degree polynomial expression, quite a mouthful. So the equation would be ax plus b equal to 0. Now when we have ax squared plus bx plus c, that's a quadratic expression, and the equation would look like ax squared plus bx plus c equals to 0. Of course, it can have a number here instead of a 0, but we can always bring it to the other side, to the left side, and make it look like this again. Now, there are many common types of equation that we encounter in the syllabus, a very common high school syllabus. The most common are the linear expression. This is the linear expression. The quadratic expression. Then we have the cubic expression that looks like ax cubed plus bx squared plus cx plus d equals to 0. So this is the cubic expression, and among them is the trigonometric expression, or the trigonometric equation. The trigonometric equation would look like this. Sine of an angle, let me call it theta as a pronoun. It can be x, it can be twice x, it can be x plus 30, anything as a pronoun. I'm using a theta. So sine x equals to 0 or some other number. Let me write a number. That's a trigonometric equation. Or cos x equals to some number. That's a trigonometric equation. So these two basic trigonometric ratios make up the trigonometric equation. Now let's talk about, since now we have a new sort of an equation and we are trying to solve, how do we solve that equation? But before that, let's talk about some basic trigonometric identities, because unless we have that, we will not be able to solve that equation. Now this time we are talking about trigonometry as more of a algebraic form, as a symbolic form, not as a practical form for finding the length of a triangle, or we can also use it to use the actual length of a building or something that we know the length of. We can measure the angle, so we can use it in construction or in engineering in a practical sense. But now let's talk about something completely abstract, something that has might not have any meaning in the real life. Of course it has some meaning later on, but at this moment let's talk about something completely abstract. Now if I think about trigonometric expression, if I think about sine x, let's talk about this trigonometric expression sine x. Now we have another thing, cos x. Now this sin x and cos x, these are the basic trigonometric ratios. So these are the basic trigonometric ratios, but now we are not talking about the ratio, we are talking about something abstract, this thing called sin x and this thing called cos x. Now the first basic identity is going to be sin x divided by cos x gives us a new creature called tan x. This is the first identity. Now let me tell you something about this symbol. We can also write an equal to sign, there's no problem at all, but this 3-line symbol is called the identity symbol, meaning sin x by cos x gives us something which is identical to sin x and cos x. We can also could have written in equal to sign, but it means they're actually identical. So from now on, instead of writing sin x by cos x, we can actually write tan x. It's a new identity. So tan x is actually coming from sin x by cos x. So this is a very important identity. So we have this one. The next identity is that the square of sin x and the square of cos x together, it's identical to 1, meaning the square of sin x and the square of cos x together, if you add it up, it is equivalent to 1. Of course, this came from various calculations. We are just going to take it as face value and remember it. Now from here we can get actually 2 more identities. One of them is this: sin square x is identical to 1 minus cos square x, and cos square x is identical to 1 minus sin square x. So these are very handy, they come in handy. So it's very important to remember that these 2 basic identities, one of them is sin x divided by cos x. Every time we see this, instead of this, we can easily write it because they're identical. So when we write tan x, we could have written this and this, vice versa. Similarly, this identity, whenever we see sin square x added with cos square x, these 2 angles has to be same. Then instead of that, we can write 1. Again, when we see sin square x, we can instead of that write 1 minus cos square x, and when we see cos square x, we can write 1 minus sin square x. So this identity is very important. The next important identity, it can be called the reciprocal identity. This is the reciprocal identity. Now what's a reciprocal? One thing that is extremely important that must be clarified between reciprocal and inverse. In algebra, what happens when we see the word inverse? It means something, this to the power minus 1, that's inverse. When we say reciprocal, by definition, reciprocal means 1 divided by that number. Since in algebra, x to the power minus 1 and 1 by x is the same thing. So what happens? We tend to think the definition of inverse and reciprocal is the same thing, but it's not. In algebra, x to the power minus 1 and 1 by x is the same thing. So in algebra, the reciprocal of x and the inverse of x might be the same thing. But in trigonometry, they are completely different. For example, in trigonometry, when we talk about the inverse is referred to as something completely different. When we talk about the inverse, so we are actually talking about an angle. So inverse of a trigonometric value is actually giving us the angle. Inverse means angle. So whenever you see an inverse, it's an angle, and it's usually referred to it as arc sine if it is the inverse of sine. So arc sine of some value, of any value. So this is in many calculators, and it's in very common practice. Instead of writing arc sine of a value, people write sine inverse of that value. So whenever we are talking about inverse, so people get mixed up. They feel that this sine inverse is the same as any x, so they feel, so sine inverse means 1 by sine. No, 1 by sine is reciprocal. They are not like algebra where they're the same. Here they're actually different. So you have to remember arc sine of a value which comes from here. If you have sine x, which is the angle, equals to some value a, then we can write the angle is arc sine of that value a. So this x is an angle, and that is denoted by arc sine. And in many calculator, instead of arc sine, we use sine inverse, and we are also used to writing sine inverse. So it's a good practice, instead of writing inverse, to write arc sine of that value, meaning we're actually finding the value. So the arc sine or the sine inverse, they refer to an angle. Remember that, it is extremely important. So the reciprocal and inverse in trigonometry, they are completely different. So let's get back to the trigonometric identities. The first thing is the reciprocal of sine x is identical to cosec x. That's the first identity, very very important. The reciprocal of sine x is cosec x. The next one is the reciprocal of cos x. It's identical to sec x. The reciprocal of cos x is sec x. And you have to remember that sine x and cos x are the basic trigonometric ratios. Tan is coming from sine divided by cos x, but nevertheless tan is important. So the next one would be the reciprocal of tan x is identical to cot x. Now the full version of cosec is cosecant. So the full version of this is going to be cosecant. This is secant. So there is a relationship between this, and this is cotangent. This is the full version. The full version of sin is sine, sine. The full version of cos is cosine, so that is sine, cosine. These are the full versions. And for tan it is tangent. That is the full version. Now when we talk about the reciprocal identities, you can also call 1 by cosec x as sin x, 1 by sin x as cosec x, 1 by cos x is sec x. Similarly, 1 by sec x is cos x, 1 by tan x is cot x, 1 by cot x is tan x. They're interchangeable. So the reciprocal identities are as important. Now along with this, there are two more identities to pay attention to. You can consider them to be more identities, because these are usually that you have to prove. Identities. So one of them is the square of tan. If you add 1 to it, it is identical to sec squared x. This is one of the identities. And another is there's a relationship between tan and cot. So the square of cot added 1 is identical to the relation between sec and cosec. This would be cosec squared x. So these two identities are usually, they tell you to prove it. They tell you to prove these two identities. So these are not something you will find very regularly, but it is something that is important as well. So the identities are the basic identities, the reciprocal identities, and the identities that they tell you to prove. Now in additional to these identities, we have something else to work on, and these are these identities. Sine 2x is identical to what? cos 2x is identical to what? These two identities are also very important, that needs to be remembered, these two identities. Now sine 2x, let me tell you briefly here, I'll move on to the next one, is 2 sine x. I'm strictly talking about algebra, I'm not talking about the practical thing, I'm talking about abstract. 2 sine x into cos x, and this is cos squared x minus sine squared x. Of course, using this identity of sine squared and cos squared, this can also be expressed as 1 minus 2 sine squared x. This is the mixed version of cos 2x, this is the sine version of cos 2x, and this is the cos version, so 2 cos squared x minus 1. So these two identities are extremely important. They can also be called as the double angle. This is double twice x, and this is x half angle. This is double twice x, this is half angle x. So these are the identities that are extremely needed for solving trigonometric equations.